Hello everybody. Today we're going to talk about trigonometric functions of any angles. So the trigonometric functions were originally restricted to acute angles. These definitions can be extended to any angles considering the standard position of an angle. Of course, if an angle is acute, then the new definition should give the same result as the old definitions. So an acute angle, what we're going to do is we're going to use the Pythagorean theorem to find the length of the hypotenuse. And note that r is always positive. Okay, so this length right here is always go. So definitions of a trigonometric functions of any angles, what we're going to do is we're going to let theta be an angle in standard position with x, y at a point on the terminal side of theta, and we're going to let r be the square root of x squared plus y squared. And that makes sense because, again, this is a right triangle right here where this is x and this is y. Okay, so that means that we're going to have these 6 trigonometric functions. So sine of theta, remember, was opposite over hypotenuse. So in this case right here, we have the opposite side as y, and we have our hypotenuse r. For cosine, that's adjacent over hypotenuse. So we have our adjacent side here, which is x, and we have our hypotenuse, which is r. And then for tangent, we have opposite over adjacent. So in this case, it's going to be y over x. Now, we don't have to go through the cosecant, secant, and cotangent because remember that those are all just reciprocals. So if sine is y over r, then that means cosecant is going to be r over y. That means that secant is going to be r over x because it's the reciprocal of cosine, and that cotangent is going to be x over y. Okay, so these are just some new definitions to help us in our oncoming examples here. So what we're going to do is we're going to evaluate the exact values of the 6 trigonometric functions of the image or of the angle or the given point. So here we have our r. So what we're going to do is we're going to find sine, cosine, and tangent. Now if we look, we're actually going to find them all, 6. Okay, so here's our angle, right? So this side right here is -3, and this side here is 4. So the first thing we need to do is we need to find r, and there's a couple different ways we can do this. We can either use the Pythagorean theorem. We can do -3 squared plus 4 squared is equal to r squared, or what we could do is we could actually use a Pythagorean triple, which is a 3, 4, 5 triangle, and r would have to be 5. So let's just do the Pythagorean theorem just to make sure that everybody knows, because I've seen a couple mistakes in grading your homework. So we have 9 plus 16 is equal to r squared, which means 25 is equal to r squared, which means r is going to be equal to 5. So now we have r, right? It's okay, whatever way you guys need to solve this. So now what we need to do is we want to find sine of theta, cosine of theta, tangent of theta. And once we do that, we can flip them to find the other 3. So first of all, sine of theta is going to be your opposite side, which is right here, which is 4, over your hypotenuse, which is 5. So it's going to be your y over r. Here we have our, by the way, you can also do this without drawing it. Here we have our -3 is our x, so we have -3 over r, which is 5, so -3/5 is cosine, and tangent is going to be y over x, so in this case it's going to be 4 over -3, or -4/3. So for our cosecant, you're just going to flip them, so it's going to be 5/4. For our secant, you're just going to flip these guys, so it's going to be -5/3, and for cotangent of theta, you're going to flip them, so you're going to get -3/4. I always try finding these 3 first because it's very easy to find the other 3 just by flipping them. Now in number 50, you do not have a drawing for this. Oh my goodness. So what I'm going to do here is I'm going to remind you guys that 3 is your x and -9 is your y. So what you're going to do in order to find this is now you're going to find r, because remember r is going to be equal to the square root of x squared plus y squared. So r is equal to the square root of 3 squared plus -9 squared, which is equal to 9 plus 81. which will be the square root of, what is that, 90, which is 3 root 10, okay? Because this will be 9 times 10, take out the 9. Okay, so now we have r is equal to 3 root 10. So now what we need to do is we're going to find sine, cosine, and tangent of this. So remember that sine of theta is going to be y over r. So in this case, it's going to be negative 9 over 3 root 10. Now you guys know that you can't leave it like this. This is not simplified. The first thing I want to do is I want to take out the 3's. So now I have negative 3 over the square root of 10. Then I have to rationalize the denominator. So now I'm going to have negative 3 root 10 over 10. And that's actually the answer for sine. Now, I'm going to show you guys a shortcut for doing cosecant, and we're going to do that next because I just want to make sure that everybody sees that you can get them quite easy once you've done all the work for one. So cosecant is the reciprocal of sine. Now, we could flip this guy right here, but then if you flip it, we're going to have a square root in the bottom. So remember that all of these are equivalent, right? Everything written here is equivalent to the next thing that it's equal to. So if I actually look at this part right here, this negative 3 over root 10, if I flip that, I get negative 10 over 3, and that's simplified. So that's my cosecant. Now you guys could have used this, you could have flipped it, and then you could have simplified it, but it would have been a lot of steps. So again, try to work smart, not hard when you're doing these kinds of math. Okay, so now we're going to look for cosine, which is going to be x over r. So we have 3 over 3 root 10. So what we can do first is we can actually cancel out those 3's. So now we have 1 over root 10. Then we're going to rationalize the denominator. So then we're going to get root 10 over 10. So cosine is root 10 over 10. Now, if we're going to look for secant, again, try to work smart, not hard here. If you guys look right here at the second step, you get 1 over the square root of 10. If you flip that, you're just going to get the square root of 10. Okay, so secant is the square root of 10. So now we have 4 out of 6 of our trigonometric functions. We've done a little hard math, but then for our cosecant and secant, we try to work a little smarter on those. So let's find tangent. Tangent of theta is going to be y over x. So we have y, which is negative 3, and then x is 3. So we're going to reduce that down to negative 3. So tangent is negative 3, which means that cotangent has to be the reciprocal of that, which is going to be negative 1/3. Okay, so we found all 6 answers to these trigonometric functions. Okay, these ones are a little bit more tricky because they had a whole bunch of radicals in there. So let's talk about the signs of trigonometric functions and the 4 quadrants. Now, some of you may have already gotten a little prequel to this, but I think it's really important to go over this in your notes. So let's talk about what's positive where. So as you guys remember, everything is positive in quadrant 1. Okay, so sine, cosine, tangent, cosecant, secant, cotangent, all positive in quadrant 1. When we look at quadrant 2, only the y values are going to be positive. So sine is positive and cosecant is positive. Okay, so we have sines and cosecants. They're positive here. Okay, so I'm just going to highlight everything that's positive. In quadrant 3, tangent is positive while everything else is negative. So tangent and cotangent is positive in the 3rd quadrant, and in the 4th quadrant, only the x's are positive, so cosine and secant are positive. Okay? This little graph over here is talking about what values for y and x are positive. We actually just talked about that. Everything in the first 2 quadrants, the y values are positive, as you can see here, okay? And this x value is negative here and here, as you can see here and here. And x is going to be positive here, and y is going to be negative here. So y's are negative in the 3rd and 4th quadrant. Again, I think the picture actually tells you what I just said a lot better than actually me saying it. So make sure you guys look over both of these because we're going to be using them a lot in our next couple of examples. So, example number 51, we're given that sine of theta is equal to negative 2 over 3, and we also know that tangent is positive. So our goal here is to find cosine and cotangent. So we know that sine is negative, and if sine is negative, that means that it has to either be in the third or fourth quadrant. So sine being negative means that this has to be either in the third or fourth quadrant. Now, tangent is greater than 0, so it's positive. And tangent is positive in 2 quadrants. Tangent is positive in the first and the third quadrant. Now, given both of these restrictions, they only share 1 quadrant in common, and that means that this has to be in the third quadrant. So this is going to be in the third quadrant. So we also know that sine is equal to negative 2/3. So what we do know is sine is equal to negative 2/3. So we know what our y and our r are. Yep, that. So I like to sketch things out. I think it's a lot easier to find what you're looking for if you sketch it out. So we know that y is negative 2. So this is going to be negative 2. And we know that r is 3. How do we know that the y is negative? Well, first of all, it's in the third quadrant. And we also know that r can't be negative. So what has to be negative here is that 2. So now we have all of this. Oops, pardon me, my phone went off. Apparently a lot. Okay. So now we have something that looks like this. So if we find x, we can find our cosine. Because remember, we're looking for cosine and cotangent. And cosine is x over r. So what we need to do here is we need to find our x. So we know that x squared plus y squared is equal to r squared. So x squared plus negative 2 squared is equal to 3 squared. X squared plus 4 is equal to 9, which means x squared has to be equal to 5, which means x is the square root of 5. So when we put this back into what we have here, we have the square root of 5 over r, which is 3. So here is our cosine. Okay. Now, the one thing you have to be really careful here is when we take the square root of x, remember that it's always plus or minus the square root of 5. And now because x is in our third quadrant, cosine is actually negative in our third quadrant. So you have to be really careful of signs here. And that's why I kind of, if we were in class, would be like, did I make a mistake here? And most people would be like, no, but we did. We have to make sure that there's a negative here because this is in the third quadrant. Now we found cosine. Now we just need to find cotangent. So what we need to do is cotangent is equal to x over y. So now we have our x is, we said it was negative root 5, and our y is negative 2. So we have negative root 5 over negative 2. That's going to give us positive root 5 over 2, which makes sense because cotangent is positive in the third quadrant. So our answers here were negative root 5 over 3 for cosine and positive root 5 over 2 for cotangent. So we've answered both of our questions here. So for 52, we're going to do kind of the same process here. We have sine of theta is equal to 4/5, so it's positive. So if sine is positive, it can be in the first or second quadrant. And we also know that tangent is negative here because it's less than 0. So tangent is negative in 2 quadrants. That's the second quadrant and the fourth quadrant. Okay, so what we need to do is we're going to be finding cosine and cosecant. So what we're given again is that these are both in the second quadrant. So we're looking for something in the second quadrant. That's 3. Second quadrant. So again, I like to sketch this out, what we're given, right? So we have in the second quadrant, we have our angle, and we know that sine is equal to 4/5. So remember that sine of theta is equal to y over r, which is 4/5. So that means y is equal to 4, and that r is equal to 5. Okay, now you guys could do the Pythagorean theorem out here, or you could remember that there's a 3, 4, 5 triangle. So this side length has to be 3. But because it's in the second quadrant, it's going to be negative 3 because x's are negative in the second quadrant. So now we have all of the sides of our triangle, and now all we have to do is find out what cosine and cosecant is. Now, For people who are just not familiar with 3, 4, 5 triangles, you could have also done the formula to get r squared minus y squared, x is equal to 5 squared minus 4 squared. That would have been 25 minus 16, which would have been the square root of 9, which would have been plus or minus 3. And then because it's in the second quadrant, it would have been negative. So again, you could use Pythagorean theorem. You could use special right triangles, whatever you need to do to get to the answer. That's fine with me. So first thing we need to do is we need to find cosine, which is x over r. And x, in this case, is negative 3, and r is 5. So cosine is negative 3/5. Cosecant is r over y. Okay, so r is 5 and y is 4. So cosecant is going to be 5/4. Okay, now, last thing we need to talk about today is reference angles. And the values of trigonometric functions of angles greater than 90 degrees or less than 0 degrees can be determined from their values, the corresponding acute angles called reference angles. Now, we dealt with reference angles when we were building our unit circle. And I briefly mentioned that we're using reference angles in order to find all of our other angles on the unit circle once we had the first quadrant. So, the definition of a reference angle, we're going to let theta be an angle in standard position, and its reference angle be the acute angle, theta prime, formed by the terminal side of theta and the x-axis. So a huge note here is that reference angles are always positive and they're less than 90 degrees or pi over 2. Okay, they're always positive. So when we're looking at reference angles, we have this angle here, but our reference angle is going to be the distance between this side right here and the x-axis. Okay, here our reference angle is going to be this angle. It's going to be positive, and it's going to be between 0 and 90 degrees. And here we have another reference angle. We have this entire angle, but our reference angle in the fourth quadrant is here. Now, you guys do have a couple little formulas in order to solve this, but if you guys sketch this out, most of the time you'll be able to do it just by looking at the angle and not by using a formula. Again, these formulas are here to help. You can use them if you want, but you'll see on the next couple of examples how we can easily find reference angles. So let's do that. Okay, so the first thing we have here is we're going to find the reference angles, and we're going to sketch theta and theta prime in standard position. So the first thing we're going to do is we have theta is equal to 300 degrees. So we know that in standard position we have our angle. It's on our initial side is on the positive x-axis, and 300 degrees is right about here. So here is our angle, and this denotes that it's 300 degrees. Now what we're looking for is the reference angle, because this is our theta, which is 300 degrees, right? We're looking for theta prime, which is in here. So what we need to do, okay, is we need to find this angle. I'm going to do here, okay? And if you look, this whole thing is 360 degrees. So what we're going to do is we're going to do 360 degrees minus 300. And our theta prime will be equal to 60 degrees. This angle here is 60 degrees. And that's our reference angle. Okay, now if you guys go back, you could see that we did use the formula 360 degrees minus our angle to get there. Okay, but that's good when the angle is between 0 and 360, but if it doesn't, it gets a little trickier. Okay, so here our answer was 60 degrees. And hopefully once you draw it out, you can see easily that it was 60 degrees. So for the next one, we have negative 135 degrees. Okay, so this means we are going in the clockwise direction, 135 degrees. And 135 degrees is actually halfway between this in the third quartile. So this angle right here is negative 135 degrees. So that is our theta. Okay, so what we're looking for is this angle right here. Okay, that's going to be our theta prime. So if you guys look at this, because it's negative, if we use this formula here on the last page, we're going to get a wonky answer. So what we can really do is we know that this angle right here, this whole angle from this side right here to here is 180 degrees. So that means that this reference angle here has to be 180 degrees minus the angle that we just drew. So we're going to get a reference angle of 45 degrees, not negative. Again, remember that reference angles are always positive. This angle right here is 45 degrees. Okay. Now we're going to start getting some trickier stuff here because now we have to graph negative 870 degrees. So again, we're going to start here on the positive x-axis. Because it's negative, we're going to have to go around in the clockwise direction. So first, we have negative 360 degrees. Then we're going to have another 360 degrees, so that's going to be 720 degrees. And in order to get to 870, we're going to have to go another 150 degrees in the negative direction. So we're going to be over here in our third quadrant. Okay, we run around the circle a couple times here. So we just talked about how we had to go another negative 150 degrees here. So that means when we're looking for this angle right here, we're looking for 180 minus 150 degrees. So we're looking for this small little angle in here. That's going to be our theta prime. And when we do that, we're going to get 30 degrees. Again, it's so much easier if you guys draw them out. You'll be able to see what you're doing without having to use all the formulas. Okay? So 56, we have 51 pi over 7. Now this is where it starts getting a little crazy because I know you guys don't like radians. So what we're going to do is we are going to graph this. So we have 51 pi over 7. So before we do this, I do want to point out that this right here is 7 pi over 7, and this would be 14 pi over 7. Okay? Because this would be pi, and that would be 2 pi. So 51 pi over 7, this would be 7, 14, 21, 28, 35, 42, 49, and then 2 more. Okay? Whew, that was a crazy one. Now the cool thing is when I was doing this, you could realize that I was not only answering the question, but I was also finding coterminal angles. So you could have done 51 pi over 7, and you could have kept subtracting things until you got to a coterminal angle within the unit circle. So you could have done minus 2 pi, which would have been 14 pi over 7 to get, my goodness, math here. You would have had to keep subtracting this 3 times. So we have minus 14 pi over 7, minus 14 pi over 7, you would actually end up getting 9 pi over 7. 9 pi over 7 is coterminal to 51 pi over 7. Okay, and that's actually going to help us with our calculations. Because if this is 9 pi over 7 here, okay, it's equivalent to 9 pi over 7, we're looking for this little area right here. Okay, so we have 9 pi over 7 minus pi, which would be this angle right here, right? But we're going to call that 7 pi over 7 to get 2 pi over 7. And that's actually going to be our reference angle. I know that one was a little tricky because we had to go around the thing so many times. Another thing you could have done is you could have turned this into degrees. Just remember that if you have an angle that is in radians, your answer also has to be in radians. So if you gave me whatever 2 pi over 7 is in degrees, your answer would not be correct. I would have to get the 2 pi over 7. Okay, let's do 4 pi over 5. This one's a little bit easier than the last one. So we have 4 pi over 5. Remember that this was always pi, or we can actually change that to 5 pi over 5, which means 4 pi over 5 is actually going to be a little less than that. It's going to be right here in the second quadrant. So here's 4 pi over 5, and that's our theta. Okay, here, this little shaded area right here is our theta prime, or our reference angle. Okay, so what we're going to have to do is, we know that this whole distance here, this whole distance is pi, right? If we subtract 4 pi over 5 from that, we will get our reference angle. So we're going to change this to a common denominator. So 5 pi over 5 minus 4 pi over 5 will give us pi over 5. And so this little angle right here is pi over 5, and that's our reference angle. Sorry, I'm losing my voice. Okay, so last one here. We have negative 11 pi over 9. So first we have our initial side here on the positive x-axis, and we're going to have to go clockwise in the negative direction. Remember that this this angle right here is pi, or 9 pi over 9. So if we're going to go negative 11 pi over 9, we're going to go a little bit past that. So this angle right here is negative 11 pi over 9. Okay, so that means we're looking for this little shaded area right here. So if we take 11 pi over 9, which is this angle measure right here, and we subtract pi, which is this angle measure right here, we will get our remainder reference angle measure, which is right there. So we have 11 pi over 9 minus 9 pi over 9. If we turn it into a common denominator, we're going to get 2 pi over 9. So our reference angle in this case is 2 pi over 9. And practice makes perfect. Okay, so to find the value of a trigonometric function of any angle, you must first determine the function value for the associated reference angle theta prime, and depending on the quadrant in which theta lies, affix the appropriate sign to the function value. Okay, so what are we going to do here? The last thing we're going to do is we're going to find two solutions to the equation given your answers in degrees or radians, and we're not going to use a calculator. So how are we going to do this? We're actually going to use the unit circle. Okay, so if you use your unit circle, we're looking for where sine of theta is equal to positive 1/2. Okay, so if you look at the unit circle, we're looking to see where the y value is equal to 1/2. So we know that we can see that this is equal to 1/2 here at, what is that, 30 degrees. But we can also look at its reference angle across the y-axis, and we can also see that it is equivalent to 150 degrees. So the cool thing about these is they actually have the same reference angle, 30 degrees, and if you look at 150 degrees, the reference angle there would be also 30 degrees. Okay, we could also write that as radians. We could say it's pi over 6 and 5 pi over 6. Now, you guys did something similar to this already on homework, so we're just going to go through this really quick. So now we're also going to see where sine of theta is equal to negative 1/2. We have 210 degrees. The y value there is equal to negative 1/2, and we also have 330 degrees. And if you want to know their radian equivalents, we have 7 pi over 6 and 11 pi over 6. Now, cotangent is equal to negative 1. That means that tangent would also be equal to negative 1. And because we don't have cotangents on our unit circle, it might be a lot easier to look for the tangent equal to negative 1. So tangent is equal to negative 1 in two places on the unit circle, and that would be in the second and fourth quadrant at 135 degrees and 315 degrees. Okay, so their radian equivalents would be 3 pi over 4 and 7 pi over 4. Now, the last one we have is secant of theta, and that's going to be equal to, I'm just going to rewrite this real quick, negative 2 root 3 over 3. And because we don't have secants on our unit circle, what it might be best is to look at cosine. So that means the cosine would be negative 3 over 2 root 3. If we rationalize this, we're going to get negative 3 root 3 over 2 times 3. The 3's would cancel out. So you're looking for where cosine is equal to negative root 3 over 2 in the unit circle. So this happens twice on the unit circle. Okay, that's going to happen once in the second quadrant and once in the third quadrant. So we have 150 degrees. And we have, what is that, 210 degrees. Their radian equivalents are 5 pi over 6, and we have 7 pi over 6. Okay, so I hopefully these last couple examples cleared up what you had questions on before. And remember that we are actually sneakily using reference angles every time that we refer back to the unit circle. Okay, so this ends today's lesson. If you guys have any questions or concerns, you can always email me or join our Google Meet. And if I don't see you, have a fantastic day.